Hello everyone and welcome back. In this video, I'm Mr. Cobalt, by the way. In this video, I'm going to be talking about the combined gas law. So what is the combined gas law? As you can imagine, the combined gas law is where all of the other laws that we learned, the Boyle's law, Charles' law, Avogadro's law, and other laws like Gay-Lussac's law, I haven't talked about yet. Uh, all of those are combined into one law, one relationship. So what do you do? Like, for example, if you have a lot of these laws, you only have a change between two things. So Boyle's law, you only have a change between, volume and pressure. Or in, Charles's law, you have volume and temperature. Or with Avogadro's law, it's volume and, amount of gas. So what if you have like more than two things changing? What if you have three or four things changing? How do you solve a problem? Well, this is where the ideal gas law, the combined gas law comes in. The ideal gas law is involved in this, but I'll cover that in a separate video. So, so what do? Well, if we go back, we remember that volume is proportional to pressure. And we saw that the reason for that is because, if you increase the pressure, then that means that the particles are hitting the sides of the container harder with more force, and that will cause the volume to increase if you've got a flexible container. If temperature and volume are directly proportional, because if you raise the temperature, you're going to make the molecules move faster. They're going to hit the sides of the container harder, increasing the force and therefore increasing the pressure, and that's going to widen the volume. Like that's, for example, in a balloon, if you have a flexible container or if you have a piston that a movable piston, and then volume is proportional to number of moles of the substance. And again, if you increase the amount of gas in the container, that's going to increase the number of molecules or particles that are hitting the sides of the container. That's going to raise the pressure, and then again, that's going to increase the volume. If you have a movable piston and or a flexible container. If you combine all of these, so volume is proportional to all three of these. So you can add this together, and you'll have volume is proportional to 1, or we have T, so T and N, so we have T and N proportional, directly proportional, so we'll put those on top. And then since we have P on the bottom, pressure, we'll put pressure on the bottom, and so volume is directly proportional to temperature and amount of gas, and it's inversely proportional to pressure. So now that we have all that put together, the way we made this inequality is we multiplied by a constant. So let's do that. We can make it into an equality. So that means that volume is going to be equal to temperature times the amount of gas divided by the pressure multiplied by some constant K, right? So we don't know what the constant is. It's just some constant that we know would make this equal. And so if we solve for K again, right? So we'll solve for K, get the constant by itself. So that means we multiply both sides by P, right? So now P cancels out here, and we're going to divide by T. And so now T's cancel out, and we divide by N. And so N is going to cancel out. And what we get is we get P times V over T times N is equal to K. And so once again, we have these are equal, all four of these are equal to a constant K. And so what we can do now is we have this relationship where if I change one, then the others will have to change in order to balance and keep K the same. So if we keep if we don't keep anything constant, then all of these are in play. So if I change the volume, then the pressure is going to have to change inversely to the volume to keep K the same. Temperature and the amount of gas is going to have to change as well to keep the constant the same. So if all of these are changing, then what we could do is if we start with initial conditions, initial pressure, initial volume, initial temperature, and then initial amount of gas. And if we change three of them, right? So if we change the pressure and we change the volume and we change the temperature, then the amount of gas would have to change in order to keep the constant. So what we could do is there'll be a second set of conditions, P2 V2 over T2 N2, that's also going to be equal to that constant, right? So once again, you have a set of conditions equal to K. You have another set of conditions also have to equal K in order to keep the constant. And so, again, according to the rule of logic, if two things are equal to the same thing, then they have to be equal to each other. And so we get P1 V1 over T1 N1 is equal to P2 V2 over T2 N2. And so in this is what we refer to as the combined gas law. So you would use this in the case that like everything is changing, right? So you start out with initial conditions of pressure, volume, temperature, and amount of gas in moles. Remember, temperature has to be in Kelvin. And then they give you a second set of conditions saying, okay, the pressure was changed to this, the number of moles was changed to this, and we raised the temperature from this to this. And then they want, okay, what's the pressure of this gas after these changes, right? So you would need to use this equation because everything is changing, okay? So this is a very useful equation. Now, you may be wondering, like, I have to remember all these equations. I have to remember Boyle's law. I have to remember Charles' law. I have to remember Gay-Lussac's law. We haven't covered that yet, but it's there too. We have to. That's pressure and temperature is Gay-Lussac's law. We have to remember Avogadro's law, right? There's all these laws. How can I remember them all? Here's the trick. You only need to remember one law, and that's this one. Why? Because I'm going to have to erase. So we got this down. So if I erase everything, right, this is why it's important to keep track of what is constant, right? So if you have a problem where there are certain things that are constant, then you can eliminate that from the equation. So this is the only equation you need to remember, right? So P1 V1 over T1 N1 equals P2 V2 over N2 T2. That's the only equation you need to remember because all the other equations are going to come from this one if you pay attention to what is constant. So, for example, if they tell me that pressure changes and volume changes, and they're asking me for like a final volume or a final pressure or something like that, and they don't mention anything about temperature, they don't mention anything about the moles of gas, then you can assume those are constant. Or they might even tell you in the problem, assume that the temperature and the number of moles is constant. So in that case, since the temperature is constant, that's going to stay the same. So look what happens when I multiply by, if I'm solving, let's say they want me to solve for pressure, right? So in order to solve for pressure, I need to get T1 on the other side. So I need to multiply by T1, right? So what happens to T1 and T2 if T1 and T2 are the same? They're constant. The temperature doesn't change. Well, it's going to cancel on that side, but it's also going to cancel on this side too. So temperature falls out of the equation. It's no longer there. So anything that is constant is going to fall out of the equation. It's going to cancel out anyway. So just get rid of it in the beginning, right? So same thing with number of moles. If I multiply by number of moles, let's say I'm trying to solve for pressure and the number of moles is constant, so I multiply both sides by the number of moles. So then N1s cancel out here, but if N1 and N2 are equal because the number of moles is constant, then that's going to cancel out too. And look what I'm left with. Look what I'm left with. Boyle's law, right? So whatever is kept constant in your problem, that's going to be eliminated from your equation. And then whatever is left over is what you use. So you can figure out the equation to use by eliminating those things that are constant. So P1 V1 over T1 N1 equals P2 V2 over T2 N2. So once again, whatever's held constant. So if you have temperature and amount of moles, if that is constant, then you cover that up and look what's left. You have Boyle's law. So you're going to use this. P1 V1 equals P2 V2. What if they tell you that volume and the number of moles is constant? So you cover that up. So volume and the number of moles, you have P1 over T1 equals P2 over T2. That's Gay-Lussac's law. Okay. What if they tell you that pressure and volume are constant, right? So you cover up pressure and volume, right? So now you have T1 N1 is equal to T2 N2. So there's your equation. Hope you can see that. So T1 N1 is equal to T2 N2, right? So depending on what is constant, you can ignore that in your equation and then use the equation that's left over. And so you don't even need to memorize what these are. You don't need to know that that's Boyle's law. All you need to know is, well, if temperature and the amount of moles is constant, then I'm going to eliminate that and I use what's left over. P1 V1 equals P2 V2, right? So I use that equation to solve this problem. So it would be nice if you know that that's Boyle's law, right? But do you need to know that it's called Boyle's law in order to solve the equation? No. So all you need to know is that this is the combined gas law, and then you can use this to solve any problem as long as you know and keep track of what is constant. If they don't say anything about it in the problem, you can assume it's constant, unless they tell you it's constant, right? So if they don't mention temperature, if they don't mention volume, then you can assume it's constant, eliminate it from the equation, and use what's left over. So if moles are constant and everything else is mentioned, then you're going to use this equation, right? So and then you solve for the unknown. Okay, I hope this was helpful. Thanks for joining me. If you like this video, please like it, share it with your friends, make a comment in the comment section, subscribe to the channel, and hit the notification bell so you can be notified. Thanks for joining me, and I'll see you next time.